Hello everyone, my name is Munjule Tamjid and today I am going to teach you node analysis. First of all, welcome to my channel, and I am now starting this channel to teach you something that you you may need in your life to go forward. So let's get back to our topic. So, what is node analysis? Node analysis is a really important topic for electrical and electronics engineering, and it is also used for many circuit analysis. So, for the circuit analysis method, no node analysis is very efficient in some cases. So, before we get started, we have to know what is a node. So, so to know what is a node, I am going to this picture. So here you can see that here is a PSpice simulator image, and I have drawn a circuit. So in this circuit I have got a voltage source, some resistors, and a current source, and then it is a at last it is ground. So what is a node? So before you going to talk about a node, before I going to talk about node, I have to define what is branch. So what is branch? Branch means that there is a component, there is one or two components in series or parallel, and they are connected between two different points, and that is called a branch. Just like that, this one is a branch. You can see that this one is a branch, and so and this one is also a branch, and you can say this whole one is also a branch. So how can we define nodes? So for nodes, we can define that node is a point where different types of two or three branches are connected. I have said that branches conclude branches take their branches have resistors or voltage sources or current sources. So we can see that branches had these things, but nodes are just points, and nodes connects two or more branches in a point. So we can call it a node, and we can call this one also a node. Now when we have a some definition of node, we can go to node analysis. So what is node analysis? For this I have got this image. This image is, you may it may look complicated, but you can see there is a ground here, there is a resistor, two resistors, one is 10 ohm and another one is 20 ohm, and there is a current source, and it is called voltage dependent current source. It has the voltages of R2, voltage across R2, and it delivers a certain type of current, which is the multiplier of this voltage. So we have to determine the voltage across R1. We have to determine the voltage across the R1, and I have this simulator software named PSpice, and here I have the value. It is 5.714 volt. So next we have to solve this problem with node analysis. So for node analysis we have node analysis we have to make these nodes with names. So I made these nodes with names. Let's just check out. Here it is our ground node. So in our ground node, I gave it a label or node name. So this node name is 0 because the ground node is always 0, and we universally fix its value to 0. And this is another node. Here it is so we have labeled it as 1. And why we are calling it a node? Because there are 1, 2, 3, 4 branches are connected into this node, and also 4 branches are connected into this node. So we have to solve this problem. Firstly, we are looking into this problem and thinking about how can we solve it. So for node analysis, we have to go the approach of Kirchhoff's current law. So that is KCL. So how can we go to KCL? We will apply KCL in node 1. So we will apply KCL in node 1. So how can we apply KCL in node 1 and make node analysis? So I have this made simple for you. Here we say that the voltage of node 1 is V1. Here we say that the voltage of node 1, we don't know what the voltage is, so we have assumed that the voltage of node 1 is V1. Then we have applied KCL. So to apply KCL, there is a brilliant, convenient way. You may have to say that there is sometimes some kind of confusion with KCL, so I have make it clear to you. So here you have taken the node, then you think like that. You think like that. You are making. You think like that. You are making a current going from node 1 to outside, and the currents are going from node 1 to outside. So here just you imagine, here a current goes from here to here, and then a current goes from here to here, and then a current goes from 1 to this way. So firstly the current goes from node 1 to node 0, then current goes to node 1 to node 0 with this way, and current goes to node 1 to node 0 to this way. So we have the conclusions. So here we say that the current 1 to node 0 on this path is going is -2, because the directions are opposite. We are assuming the direction here, but the direction is here. So we have taken -2. Then plus V1 minus 0, that means the voltage across this R1 resistance, and then V1 minus 0 divided by 10. Then plus V1 minus 0 divided by 20. That's the voltage across this node. Sorry, the voltage across this R2. And at last there is a current going from this node to 0. So the current is 0.2 V1. So the gain of this voltage dependent current source is 0.2. So this is 0.2 V1. So we have got all these things, and in this case KCL, when you assume that the current is flowing from the node to outside, and you sum up those currents, and you will get 0, and it is universal, and this is a very convenient way to solve a problem of KCL. You just assume the node, and the current is flowing from node to outside, and then you sum up those currents, and sum up those currents in the left hand side of the equation, and put 0 on the right hand side of the equation, and then solve this equation. And I have solved it, and we have got 5.714285 volt, and from this we can have 5.714 volt, and this is really really correct. So we are going to our next circuit, our second circuit. So in our second circuit, it is really complicated because here we have got some problems. In the first circuit, here we go. In the first circuit, we had a current source and another current source. It is voltage dependent, but it's actually a current source. But in the second circuit, we have a voltage source. So when voltage source is present in node analysis, this is a really a problem, and we have to go supernode approach. So what is a supernode? Supernode may seem a really new topic, but supernode is a really easy way to solve this problem. So what is a supernode? Supernode is a voltage source which is connected between two branches. Supernode is a voltage source which is connected between two branches and two nodes, and this supernode acts as a node. Okay, this supernode acts as a node. So firstly we are going to label this. So we are going to label this one. So we are going to name the nodes. For naming of the nodes, we are writing this is node 0 because it is ground node, then it is node 1, then it is node 2, then it is node 3, and it is node 4. So how can we solve this? For solving this one, I have going to this approach. Here we can see V1 is equal to 10 volt. We can go back to here. V1 is equal to 10 volt because in this node we have assumed this is V1 and this is V2, the voltage of these nodes, and this is V3 and this is V4. So V1 is equal to 10 volt because the positive side, the negative side of the voltage source is on the ground node, and the positive side of the voltage source is on the V1. So the V1 is 10 volt. Then V2. So we are going back to our problem. V1 is equal to 10 volt. So applying node analysis in node 2. So we are applying our node analysis like we have applied in our first problem. So applying node analysis in node 2. So we are going to take V2 minus V1 divided by 10 plus V2 minus 0 divided by 10 plus V2 minus V3 divided by 10 is equal to 0. This is how we can measure the KCL, because V2 minus V1 divided by 10 means the current is flowing from this way to this way. So I can make it clearly that V2 minus V1 divided by 10 means the current is flowing from here to here. V2 minus 0 divided by 10 means the current is flowing for V2 from here. V2 minus V3 divided by 10 means the current is flowing from here to here. So we can see that the summation of these three currents are always equal to 0. So we are applying this. V2 minus V1 divided by 10 is plus V2 minus 0 divided by 10 plus V2 minus V3 divided by 10 is equal to 0. So we are solving this. We have got equation number 1. So then we are going to say that here is a dependent source E1. So E1 is a dependent source and it's a voltage source. Most importantly, it's a voltage source and it is connected between two branches. So we can say it is a supernode. So for a supernode, we will consider this whole thing will as a node. So we will make a node analysis in this node. So for the node analysis, we can say that this current plus this current plus this current is equal to 0, because for the node analysis we have already said that. So V3 minus V2 divided by 10 plus V3 divided by 10 plus V4 divided by 10 is equal to 0. So we have got another equation, the second equation. So we are going forward, and then at last, so when Whenever we have make a supernode, then we will have to make Kirchhoff's voltage law. So here you can see that V4 minus is V4 is the positive end of this source, and the V3 is the negative end of this source. So V4 is equal to V4 minus V3 is equal to this voltage source value. So we can say that V4 minus V3 is equal to 5Vx. So the gain of this voltage source was 5. So the gain of this voltage source was 5 Vx. Vx means our voltage of this is Vx. So you can see that this is Vx, and this is 5Vx. So we can have to go to the next image. Yes, this is Vx and this is 5Vx, and here you can see this is V4 minus V3 is equal to 5Vx, because it is the positive. V4 is the positive end of that source, and V3 is the negative end of that source. So V4 minus V3 is equal to 5Vx. So I hope you are clear. So V4 minus V3 is equal to 5x, and Vx is equal to V2 minus V3. So how does this come? Look at this. Vx. Where is the positive end of the Vx? Here. Where is the negative end of the Vx? Here. So Vx is equal to Vx is equal to V2 minus V3. So here you can see Vx is equal to, because we have got positive minus the negative. So Vx is equal to V2 minus V3, then V4 minus V3 is equal to 5 into V2 minus V3, because it is Vx. So we have third equation. So we are going to solve it. So when we are going to solve it, we have assumed that x is equal to V2, y is equal to V3, and z is equal to V4. So we have made that equation. You can pause the video here and go back to the video and see what I have done. This is just simply a formula, and we have got x is equal to 10, that means V2 is equal to 10, y is equal to 20, that means V3 is equal to 20, and z is equal to minus 30, that means V4 is equal to minus 30. So we have got this. So we have got these results, and this is our tutorial about node analysis. So give me feedback in the comment section, and this is my first video, so pardon my mistakes, and goodbye. And I think you all will appreciate me, and I will make more videos.